Now let's talk about container networking in Docker. So Docker networking is based on the Linux network namespaces, and so this allows you to create a complete communication stack from images, and that stack will be running on the Docker host. So when we execute a container or a set of containers from distributed service, we can use the --net option to choose between those network modes. And there are a few modes there. You can use the default bridge, a different bridge, or not provide access to network at all. So here you have some of the options that you can use with the net option. So the first one is the net equals to bridge, and this is the default behavior and creates a new network stack from the container in the Docker bridge. The next one is if you choose the option none, which allows you to execute the container without any network connection. Then you can use the host option, which means that container uses the network stack directly from inside the container. And finally, if you choose the my container option, this will inform Docker to start the container with capacity for using the container network stack. So let's have a look at the Docker network options. Now you can access the Docker network options by writing Docker network, okay? And you can see that you can actually create a network, connect a container to a network, disconnect a container from a network, inspect a network, check for the available networks, or remove either the unused networks or a specific network that you want to remove. So if I do Docker network ls, you can see that we're having a few networks that are currently available. And for example, if you want to remove, of course, you will do Docker network rm and the particular network, or you can do Docker network prune in order to remove all networks that are not used in the latest container. So if I hit yes here and then I rerun Docker network ls, you can see that we removed the Docker GW bridge since it is not used in at least one of the containers. So if you want to initialize a container that doesn't have any communication with any network, you can use the none keyword. So let's try to do that. Let's do Docker run --net equals to none -it for interactive --rm, and let's run the Debian distribution. Okay, so let's hit that, and you can see that now we're into our Debian distribution right here. Okay, so let's exit this network. This is how you can create a network without actually container without any network. So if I run the same container, but here I write, let's say latest, okay, so use latest version, bin bash, okay, you can see that we just activated this Debian network with Debian container with no network assigned. And so if I open another terminal while this container is running, and if I do Docker container ls, and I can use this ID for the container. So let's do Docker inspect, then let's use the container ID, let's do a pipe, and then let's do grep -i addr for address. And you can see that when we create a network or a container without a network assigned, you can see that we actually have no IP addresses assigned to that container whatsoever. And this is a proof that the option actually worked. And even if you try to connect any network to this Debian container, this will actually not work. Okay, so let's exit the container. And the next thing I want to talk about is about bridges. So let's see how we can actually create a bridge or communication between two containers. Now, firstly, we're going to use Alpine image in order to create those. So let's do Docker run dit name alpine1 ash. Okay, and this is denied because I need to also add the actual image, which is Alpine. Okay, so let's run that again, and you can see that now we have another container called Alpine, which is good. Now let's create another one called Alpine2, and I will show you how you can connect those. Okay, so now we have Alpine1 and Alpine2, and if I do Docker container ls, you can see that we're having two Alpine containers currently working. So now let's do Docker network inspect bridge. Okay, and this will give you So here you see what containers are connected to the current bridge that we're using. So you can see that actually the two containers are working together, because if you check the bridge that we already have, which is I had to say the default option, so by default the containers can communicate between each other. So if we check the current bridge and you go down here to containers, you see that you have the Alpine 1 image with the endpoint ID, and you also have IP address of that image, and on the other side you also have the Alpine 1, which is the other image that is also included in the bridge, and it has IP address as well. Okay, so now let's do docker attach Alpine 1. Okay, and so let's now display, so right now you're in a Alpine 1 container, and let's now display the addresses. So let's do IP addr show, and you can see that there are a few interfaces. So the first one is the loopback device, while the second interface, or actually the third one because we are ignoring the tunnel, has the IP address of 172.17.0.2, which is the exact IP address of Alpine 1. So while you're in Alpine 1, let's make sure that the networks actually work on Alpine 1. So you know, if you're using the none option, you'll not be able to use any network. So since we didn't use it, we should be able to actually ping or connect to any external web page. So let's do ping-c to google.com. Okay, and you can see that from here you can actually ping Google, which means that your network connectivity actually works. Now let's check if we can actually connect to the other container. So if I see this is the IP address of Alpine 2, right? So if the bridge works properly, you should be able to ping this IP address. So let's do ping-c to, and then let's use the other internal IP address. So let's hit enter, and you can see that we're also having network connectivity to the other container, which is this IP address, which means that the two containers can communicate properly. However, if you do not use the IP address of Alpine 2, you can see that you're getting bad address Alpine 2, so you cannot use that. Okay, so our experiment is successful, and you can see that by default the containers are connected successfully together, and they can communicate with each other as well as with the external network. So let's exit this container right here, and I'll close both containers in order to end this in a good state. So let's do docker container stop Alpine 1 and Alpine 2. Okay, and you can see that now Alpine 1 is closed, and soon Alpine 2 will also get closed as well. Okay, and now let's remove both of the containers so you don't have them in the backlog. So let's do container rm Alpine 1 and Alpine 2. So that would be everything for today, guys. Thank you very much for watching, and in the next video we will talk about how the containers can communicate with each other and port mapping.